Hello everyone, this is a video about finding the points that a curve crosses itself. So suppose that you have a curve whose parametric equations are x is equal to f of t and y is equal to g of t, and f and g are functions from r to r. And also suppose that the graph of the curve is something like that and the curve crosses itself at this point. Further, suppose the direction of the curve is like that, right? So now suppose that you have a particle here and this particle starts moving along this curve, and at the time t0, so at the time t0, the location of the particle is here. And then the particle keeps going along this curve. And after some time, let's say t1, the particle meets this point again. So now we want to find the coordinates of this point, right? We want to find the x and y for this point. So what is the location of the point at t0? It is f of t0 and g of t0, right? Why? Because x is equal to f of t and g and y is equal to x is equal to f of t and y is equal to g of t. And what is the location of the particle at t1? It is f of t1 and g of t1, right? Now, because the location of the particle at t0 is the same as the location of the particle at t1, so this equation is equal to this one, right? So therefore, to find the coordinates of this point, so it's enough to find t0 and t1 such that number one, t0 is not equal to t1. Why? Because the particle meets this point after some time, and we call that time t1. Therefore, t0 is not equal to t1. And number two, based on this equation, f of t0 is equal to f of t1, and f of t1 is equal to g of t1, right? So this is all we need to find the coordinates of this point, right? So let's solve an example and clarify things more. So example, find the points that the following parametric curve crosses itself. So we can call this as f of t and this g of t, right? So we now it suffices to find t0 and t1 such that, as we discussed, number one, t0 is not equal to t1, and number two, f of t0 is equal to f of t1, and g of t0 is equal to g of t1, right? Now let's just substitute things here. So f of t0 is 1 minus t0 squared is equal to f of t1. So f of t1 is equal to 1 minus t1 squared, right? And here g of t0 is equal to, okay, t0 minus t0 to the third is equal to g of t1, and g of t1 is equal to t1 minus t1 to the third, right? So therefore we have to find T0 and T1 satisfy these equations, right? So let's start with this one, with this equation. So T0 minus T0 to the third is equal to T1 minus T1 to the third. So let's factor T0 from this side. T0 times 1 minus T0 to the T0 squared. And let's factor T1 from this side. So therefore we have T1 times 1 minus T1 squared, right? So now using this equation, right, and substitute 1 minus T1 squared by 1 minus T0 squared. Therefore, we have T1 times 1 minus T0 squared, right? So therefore what we have here is T0 1 minus T0 squared is equal to T1 1 minus T0 squared, right? Here we go. So we make it easier. So therefore if 1 minus T0 squared is not equal to 0, therefore we can divide both sides of this equation by 1 minus T0 squared, and then what we get is T0 is equal to T1. But this is not what we wanted. Why? Because condition 1 says that T0 is not equal to T1. But if now 1 minus T0 squared is equal to 0, then what we have is T0 squared is equal to 1, and this implies that T0 is equal to positive or negative 1. And because 1 minus, as you see here, right, as you see here again, right, 1 minus T0 squared is equal to 1 minus T1 squared. 1 minus T0 squared is equal to 1 minus T1 squared, and T0 is equal to positive or negative 1. So if you substitute T0 here, what you get is that 1 minus T1 squared is equal to 0. And then what you get is T1 squared is equal to 1, and then T1 is also is equal to positive or negative 1, right? So therefore, if you choose T0 is equal to negative 1 and T1 is equal to positive 1, you can easily check that f of T0 and g of T0, right, is equal to f of T1 and g of T1. And look at here, so just substitute T0 and T1. So then here what you get is equal to 0 and 0, right? Here, if you wanna I want to clarify this part more, because just substitute T0 is equal to minus 1, T0 is equal to minus 1 here, so then x is equal to 0 and y also is equal to 0, and for T1 also the same. So therefore T0 is not equal to T1 because it is T0 is equal to minus 1 and T1 is equal to positive 1. But the location, right, the location of the particle in T0 and T1, right, is the same. So if you look at the if you look at the graph of the curve, so the particle starts from here, and it starts from here, and the particle moves along here, and at t0, let's say is t0 is equal to -1, the location of the particle is here, and then the particle keeps going, and then after t1 is equal to 1, the particle again meets this point. Okay, I hope that this video is helpful for those of you who asked me this question. Thank you very much for your attention.